started top-down parsing, and to understand top-down parsing and how it is being implemented here. In last lecture, we have already discussed about the organization of organization of the top-down parser. This is we are going for LL1 parser here, left to right and left to right. So LL1 means, like, look at here. We are going for LL1. Okay, so LL1 means left to right with look ahead, value of that look ahead value is 1 symbol. Okay, so this is left to right with look ahead value 1 symbol. So which means that simple case is that if you have all reduction onto the stacks, then the look ahead value is that your pointer is pointing to one symbol at a time in from the input string. Once the content of the stack and means top of the stack gets matched with the input string, we are going to reduce. Okay, so that is reduce action. Okay, so whenever you are shifting any symbol onto a stack, it is push action, and when you go for reduce, that is a pop action. So you are trying to remove that particular symbol out of stack. Okay, so this is simplest part is there. Okay, now we are learning this particular parsing technique now. Okay, and the key pointers for this particular parsing technique is, like, whenever you are provided with the grammar, this is the grammar, you have to understand whether the grammar is containing left recursion or not. If the grammar is containing left recursion, you remove that left recursion and reorganize the grammar. So see, this is the original grammar that you are going to have. You are reorganizing this grammar into this particular form. E implies the dash. So here, if you look at E is in case of left recursion, what you will observe, you'll observe that the symbol which is present, or the variable which is present to the left hand side, appears as the first symbol into the right hand side of the expression. The same symbol appears to the right hand side of the expression. So in that case, the left recursion happens, and it is very difficult for an parser to handle those left recursion. So it is mandatory for us to remove the left recursion and reorganize the grammar. So when we remove the left recursion, then you reorganize grammar in this particular way, such that E implies T dash, E dash is plus Te dash or epsilon, T is Ft dash, T dash is star Ft dash or epsilon, F is employing opening bracket, closing bracket, A. Okay, so which means that this is the modified grammar, uh, which means that this is modified grammar, and we understand this grammar, or we refer this grammar with what we can say, with numbers. So this is zeroth number production, this is one number production, this is two, this is three, this is fourth number production. So we have got four productions. So ultimately you can have this as like 1.1, T employ 3 is 3.1, 4 is 4.1. So means if you look at this is going to be a 4.1 production, this is 3.1 production, and this is 1.1 production, right? So it just for your reference, right? And these numbers we are going to write it into the action tables. Okay, so now we understand that whenever the grammar is being provided and you are asked to go for a LL1 parsing, you need to go convert. You need to see the checkpoint is whether it contains left recursion. If it contains left recursion, modify the grammar, rewrite the grammar by eliminating left recursion. Okay, so by that you will understand that input string is going to what input string that it is going to form. Okay, so the for example with this grammar, the input string is dollar $a plus a star a, and this is dollar. Okay, now let us look at this, how this is being formed. This is being formed in very simple way. E implies E plus T. Okay, in original, if you look at E implies E plus T, uh, E implies T in the original form, T implies F, F implies A. Okay, this is plus, and this is T is T star F. Okay, T is F, F is A. Okay, and F is A. So actually this is going to form, right, in this way. But since this is left recursive form, so we are going to eliminate. So means what, like in this case, this is going to be TE dash, E dash is plus TE dash and all in that particular way it is going to form. But overall, the substitution goes into this particular way. How we can reach to A? We reach to A by T, T to F, and F to A, right? So means this is the path which we need to follow. But in this case, we have to see like here, the stack is there, so stack is empty. So what we are going to do is we are going to just push. We are going to just push dollar. So what is remaining is A plus A star A dollar. Okay, then what is going to have? So we need to go for a production so that we can match our substitution on the stack with respect to the input string. Okay, so we'll say, okay, we'll say with we start with the leftmost non-terminal, that is E, and then what is left is say A plus A star A dollar. So E is TE dash. So this is going to be reduced. So dollar E dash T. Okay, so E dash T is being formed. So what is T now? T is F T dash, because F is giving me this. So uh, so we are going to write dollar E dash, T dash, and F. So what is at the top of the stack is F. F, okay, A plus A star A. Okay, so here F is going to be reduced with A, right? So we are going to write, say, dollar E dash T dash A, and this A. So plus A star A and dollar. So means what, this is being reduced. So this top of the stack and this gets smashed. So we are ultimately reducing this. We are popping off this. So which means that F implies A. So the action is here. We are going to pop. Okay. So what is left onto the stack is E dash T. Okay. E dash T dash. Okay, E dash T dash. Now, what is left onto the input string is plus A star A dollar. Okay, now 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 we understand that if we wanted to get plus as an input string, this T has to be reduced with the production with production T dash implies epsilon, so which is nothing but 1.1, rule number 1.1 production. So by that T dash gets reduced, right? So here we are going again with performing a pop operation, we'll reduce it. Okay, so but E dash is now E dash T uh, plus T E dash. Just a minute. So this is okay, it is just plus TE dash. So you have got plus TE dash. Now plus plus gets matched here, plus gets matched here. So so this is plus get matched. So what is going to happen? A star A dollar. Okay, so the plus get matched here. Okay, so what is left now? This is TE dash, right? T is now what is here is dollar. What is here? E dash is T A star A dollar. Okay, okay. Now what is now? Okay, now in order to get this in order to get this particular A, what I need to do is uh, what I need to do is here here we have to go for uh, mm, T is say T is FT dash, right? So what we need to do is dollar T is E dash T dash F. Okay, so which means now here what is left is this. Okay, so T is FT dash. So T is FT dash means what? By production number, uh, T implies FT dash. So this is nothing but production number 2. We did reduce it. So F is gonna be A. Okay, F is going to be A. So this is we are going to reduce, say, here, here, so this is cut, this is cut. Okay, so now F dollar E dash T dash A, so A star A dollar, so this is going to be popping off, right? Okay, so what is left is dollar E dash T dash star A dollar. Okay, and we know that dollar T dash, now it is star, so means what? T dash implying FT dash. Okay, so E dash is um, T dash F and star. Okay, this is going to be star A dollar. So this star and this star is going to be moved off, right? So dollar E dash T dash F. So F is now what is left? F what is left is A and this F. So dollar E dash T dash F is A. This is A dollar. So this is going to be reduced. So here we are going to write an action as F implies A. Now here forgetting this, we'll say, right, T dash implies star F T dash. Okay, then you have got it, right? So what is left is E dash T dash. Okay, what is this? Dollar. So E dash T dash is dollar. So we know that dollar, this E dash and T dash, E dash will say T dash is T dash epsilon. So what is going to happen? Only E dash remains dollar. So again E dash is going to be epsilon. So what is remain? Nothing. So this is dollar. So when a dollar is going to be on top of the stack, it is a accept. Okay, so we have got all the productions. So this is how the table stack representation is going to happen. Yesterday in last lecture we could find up to this one. Okay, and due to the time we stopped, but this is how it is going to